Hi, everybody, and welcome back to Get That GED. I am Dr. Robyn MacKillop, and today we're going to do surface area for geometry. All right, hold on a second and I'll switch cameras and we'll get going. All right. During your math test, actually during all of your tests, you will have this available to you. It's the GED formula sheet. Super important. If you can get your hands on one ahead of time, do it. I can send you a copy because you should become familiar with where things are on it. It's available to you for all tests. You don't need it for language arts, but you might need it for social studies and you might need it for science because you've got some other things down here. Mean, median, here's all your algebra equations, quadratics, Pythagorean theorem, interest, distance, total cost. And up here, we've got the area of the various shapes, the perimeter and circumference, and then the surface area, which we're going to do today, and volume. So the nice thing is you don't have to memorize anything. You will have this resource available at any time during the test. The other nice thing is they remind you what pi is. Because if you've ever been in a stressful testing situation, sometimes things that you absolutely know go right out the window. So if for some reason you forget pi, it's right here, 3.14. All right, let's try a couple of these. I'm going to start with a sphere. And the surface area of a sphere is 4 times pi times radius squared. So we look at a sphere. A sphere is a ball. And the formula again is 4 times pi times radius squared. So for this, we're going to take a look at, double check your radius always, because you see in this one over here, they give you a diameter. You have to make sure you cut that in half. But here they give us a radius, so we're good to go. We're going to set this up as 4 times pi is 3.14 times the radius 34 squared. So that is the setup. And then get really comfortable using your calculator because it will make things on the test go so much faster. And as we all know, the timing is what gets most students. Everyone would pass these tests if they had enough time, but that little timer clicks down and the majority of students who don't pass, it's because you don't have enough time. All right, so let's punch this in. We've got 4, whoops, I need to turn it on. 4 times 3.14 times 34. And then on your calculator, you can do exponents. This little tent button, kitty corner from the 7, click that. You see that it gives you the exponent. 2, arrow out, so you're out of that mode, hit enter. So the surface area of this particular sphere is 14,519.36 square yards. Now, another one that you will likely see on the test is a sphere that's cut in half. The problem with this is not half a sphere. So it's not like you figure out using this formula and then just cut it or divide it by 2, cut it in half or divide by 2. This counts the top round. This is a solid. When you're evaluating a sphere, you don't have any hard edge. It's just round. But here, this is a hard edge, this circle. It's like taking an orange and cutting it in half. You still have a surface and you have to count that surface. So it's not as simple as saying, oh, let me do this and then cut this formula or cut the answer in half. This has its own formula and this is not on your resource sheet. So commit this to memory. 3 times pi times radius squared. So same formula essentially, For a full sphere, you use 4. For this half sphere, use 3, and this will include that round surface. And again, we already have the radius. We don't have to cut that in half or anything. It's already ready to go. So let's punch this in. 3 times pi is 3.14 times the radius is 23. And then you hit your little tent button here, kitty corner from your 7, pops into exponent mode, 2, and then arrow out, hit enter, 4983.18. 4983.18. I'm going to try this one as if we were going to cut it in half so you can see the difference. So let's just say, let's use the normal sphere formula. So that's 4 times pi, 3.14, times 23 squared. So if this one happened to be a full sphere, it'd be 664424. If it was all the way around, 664424. And if we thought to cut that in half, that would be divided by 2, 3322.12. See the difference? Big difference. So you don't want to just assume that you can do this as a whole sphere and cut it in half. You have to do it with the 3. And then that includes that round portion. All right, let's try a couple others. Let's do a cone. All right, the cones are interesting because sometimes they're more work than they're worth. I'm going to do an easier cone first. I'll show you why. We're going to start with this cone. And the formula for cone is pi times radius times side plus pi r squared. So let me get that written down so you can see it. Pi times radius times side plus pi radius squared. So what's interesting about this formula is this portion of the formula includes the solid bottom, the circle on the bottom. So if you had a test question that asked you to find the surface area of an empty ice cream cone, you would cut this part off because that would be the surface area of the outside of the cone. This includes the round portion on the bottom. So this is a solid cone. But if it's an empty ice cream cone, you don't have that solid piece at the bottom or the top. So these are things you have to keep in mind. This is where they trip you up. You've got this formula, but if they say you're finding the surface area of an ice cream cone that does not have a solid top, you need to eliminate this part of the formula. All right, let's type this one in. Pi again is always 3.14. So here we've got 3.14 times the radius, which is 18, because this is a diameter. So our radius is 18 times 18 times the side. So they give us a side, 43. And then we're going to figure out the bottom by continuing. Pi again, 3.14 times the radius, 18 squared. Use your little tent button to arrow out of that. 3447.72. The one thing that is troublesome with geometry, there's no good way to check your work. There's no way to take this answer and plug it in somewhere to find out if you calculated correctly. you're really forced to look at what you typed in and make sure that it went in the right way. Because these answers can be all over the board depending on what the measurements are. All right, I'm going to show you a harder cone. And it's not that it's harder per se, you just have more steps. And let me get a piece of paper. All right, so here, same exact formula, and you'll see the difference in a second. Let me write the formula down. It's pi times the radius times the side plus pi times radius squared. Okay, so the same thing is happening here, exact same formula. This is calculating the solid top, this round portion. That is what that is calculating. So we're going to type in 3.14 for pi times 21 is the radius. But here's where we run into an issue. What is the length of the side? 42 is the height. It is not the length of the side. And when you look at this, there's the triangle. You have an extra step. You have to use the Pythagorean theorem to figure this one out. And the Pythagorean theorem, again, is on your resource sheet right here. A squared plus B squared equals C squared. And that is what you have to do in order to find the length of the side. So A squared plus B squared equals C squared. So it doesn't necessarily make the problem harder. It's just longer. It's more work. So we're going to take 42 squared. It doesn't really matter what order you put A and B in, plus 21 squared equals C squared. C is always the long side of a triangle. So we grab our calculator. 42 squared plus 21 squared, arrow out of that, 2205. So C2 equals 2205. How do you get it to the C? We need the square root of 2205. So again, on your calculator, right here, you've got the square root button. It's at the top in green. So you click your green button, then your square root button. Let me bring that back down so you can see. 2205. It's going to be about 4696. So C equals 4696. If they don't specify, normally you round decimals to the 100th, so to the second place. And that's where I got the 46.96. All right, let's come back to our cone. This side is now 46.96. Just an extra step. Let's come back to our original equation. We've got pi, we've got the radius is 21 times the side, which is now 46.96. And I'm going to calculate that portion out first, and then we'll do the round. Make sure you can see this here. Let me move this over. All right. So 3.14, that's pi, times 21 is the radius, times 46.96. So our surface area of the cone portion is 3096.54. And we add this to pi radius squared. It's a long problem when you have to find the side. It's just a whole nother set of procedures. So we've got 3.14 times the radius 21 squared. Arrow out of that. So the surface area of this cone, including the round portion, is 4,481.28. So hopefully that made sense. The first cone we did already gave us the side. We had the length of the side. But when we came up to this cone, we had the height, not the length of the side. So we had to use the Pythagorean theorem to figure out the length of that side. Then we can go back and plug in everything into the formula, and we get our answer, which was 4,481.28. I'm going to do one more. I'm going to do a cylinder just because these aren't as easy to access. We don't deal with cylinders nearly as often as rectangles and squares. So you can see here, the cylinder formula is 2 times pi times radius times height plus 2 times pi times radius squared. So I'm going to write that down so we've got it. It's really small on the formula sheet. 2 times pi times radius times height plus 2 times pi times radius squared. All right, here we go with a cylinder. What the second part of this formula is calculating is the top and the bottom. So the lid and the bottom surface, that's what the 2 pi r squared is. If, for instance, on your test, they asked you to find the surface area of an opened can, you would get rid of the 2. You would just use pi r squared because that would be the bottom. The top would be open, just like a can that you emptied. If it happened to be something like a tree wrap, there is a problem on the GED math test that's free on GED.com that talks about a tree wrap. Well, when you look at a tree and they wrapped the tree, it doesn't have a top or a bottom. It's just the surface area in the center. So in that case, you eliminate this part altogether and you just do the 2 times pi times radius times height. I know that sounds confusing, but you have to be able to think about what they're asking you to measure. Because if you have a cylinder that has an open top, like an open can, and you use the whole formula, you're not going to get the right answer. And if it's a tree wrap or something like that, like a paper towel tube, and you use this, you're not going to get the right answer. So this portion measures the surface area around. This portion with the 2 measures the top and the bottom. All right, let's try this one. We're looking at, clear that, 2 times pi is 3.14 times the radius. Now right here, they gave us a diameter. We need the radius, which is half of that. So the radius is 12 times the height, and they gave us the height, 27. And I like to do 1/2 at a time, just in case I mistype. I don't want to type the entire formula in again. So I just keep notes so I don't have to redo the whole thing. Now, since this says both top and bottom, we're going to continue with this portion. Plus 2 times pi, 3.14, times radius, again, is 12, exponent, button, 2, arrow out, enter, 2939.04. 2939.04 square feet. All right, I hope that was helpful. We, on another day, we will do rectangles, triangular prisms. There aren't any pyramids on this either. So on another quick class, we'll do rectangular prisms, triangular prisms, and pyramids. All right. If you need any help, please send me a message. And if you'd like some of these worksheets, also send me a message and I'll send them to you. All right, everybody. Thanks very much and have a great day.